Happy Thursday, everyone. Hope that you're having a great day. Sorry that I'm not with you today. I had to step away, and I will be back tomorrow. So, on tomorrow, what I ask is if you had any questions for last night's homework assignment. I know that it's technically due today, but if you would just hold on to that, I will answer those questions on Friday when I return. Anyways, if you are real confident in what you put on everything, then go ahead and turn that in. But I won't be grading those until probably Friday or this weekend anyways. So don't worry about turning it in today. Hold it till tomorrow. If you have questions, then I'd love to answer it. So today, hopefully you have already been distributed the normal distribution note sheet, and we're going to go over that now. And I'm going to hopefully see you guys do a good job on this because it's really not that hard. It's got some tricks to it and some memorization that actually you would need to do in order to be real successful with it. But just conceptually, it's not that hard of a topic when we talk about normal distribution. Okay, so anyways, when we gather data, occasionally you'll have data that will be gathered that look like the first two occasionally. Now, I know that it looks like this thing is going down, and when we think of going down, we think of negative. But if you have more data on the left side than you do on the right, this is called positively skewed data. Positively skewed data. So what do you think this one is that's actually going up? We think positive, but when there's more on the right than there is on the left, this is actually called negatively skewed. And these are rare. Okay, generally, when you gather data, it's not going to look like either of those two. Okay, most of the time, when we gather data for most normal things, it is going to show this curve that we have right here on the far right. This is what we call, and it's called this for a reason, it's called normal distribution. It's called normal distribution because it's normal. This is the way we're accustomed to seeing it. Okay, this is how most data is. It has this normal curve to it. In fact, if you trace that curve, and I'll do it with a highlighter, if I trace that curve, it kind of starts low and it goes up and then it curls back down. Does anybody know what this is called? You maybe heard it called a bell-shaped curve. A bell-shaped curve. Normal distribution has what we call a bell-shaped curve. Okay? Now, being that whatever that curve is representing, that's going to include 100% of your data. So the area under the curve represents basically probability. And whenever we deal with probability, it's out of 100%, right? So therefore, the total area is going to be equal to 1. Okay, 100%, 1. So this is what we're talking about today. We're talking about normal curves. Now, we kind of started, I said normal curves, bell-shaped curves. I kind of mixed the two. We're talking about normal distribution. So yesterday we kind of addressed this when I was showing you guys the calculator, how to run a one variable statistics. I told you about this thing that we call an upside down Q. And that upside down Q stands for standard deviation. Standard deviation. That needs to be a term that you are very familiar with. Standard deviation. So, and I'm running out of space here, but standard deviation is representing the values that exist under a curve. So here's how it works. When we look at a normal curve, which represents our normal distribution of values, right smack dab in the middle is going to be your mean, your average. We called it mu yesterday, but we also called it X bar, right? X bar is when we're talking about statistics, when we're talking about a sample. Mu is when we're talking about an entire population. So my mean is right there in the middle. And if you notice, off to the left and off to the right, it goes one standard deviation away from the mean. This first bar is one standard deviation away from the mean. So all of this area right here is considered one standard deviation away from the mean. Now go up above this just a touch. When we talk about one standard deviation away from the mean, there's approximately 68% of all of your data that falls 1% or one standard deviation from the mean. Now, divide that 68 in half. What do you get? You get 34. So approximately 34% lies here and 34% lies here. Okay? Now, the next group, if you look down at the bottom, it includes two standard deviations away from the mean. Two standard deviations away from the mean. So this next little area here, here's how you calculate this. Well, how much of my data lies two standard deviations away from the mean? 95%. 95% of your data lies two standard deviations from the mean. Well, how much of that 95% is already gone? Well, 68. 68% of it's already gone. So 95 minus 68 leaves me with how much? 27. So only 27% falls in those little red areas that I've highlighted here. So what is 27 divided by 2? Well, 27 divided by 2 is 13.5. So 13.5% lie in both of these two locations that are two standard deviations away from the mean. Okay? So then you have the third spot. And the third spot is 3 standard deviations away from the mean. And look how small these little slivers are. They're really little, right? That's 3 standard deviations away from the mean. Well, there can't be much left, right? 99.7% of all of your data is 3 standard deviations away from the mean. Well, again, how much is left over? We've already used 95%. So what's 99.7 minus 95? Well, that's 4.7. So 4.7% lies in those two little blue areas. Well, what is 4.7 divided by 2? 2.35% live here and here. 2.35 in both. Okay? And then, like always, you're going to have these things out here that we call our outliers. There are those values that are kind of far-fetched. They don't really match the data. They're way outside of what's normal. So what lies out there at above or over 3 standard deviations away from the mean? Well, 100% of the rest of your data, right? And we've already used 99.7, so that's only 0.3%. So I have 0.3% lying in those outside pieces. Well, divide that by 2. That means there's 0.15% here, and there's 0.15% here. Okay? Now, step back and look at this. This is what you need to memorize so you can kind of redraw these with all of our different problems that we're dealing with when we've identified your mean and your standard deviation. Okay, so let's actually put this to work. And hopefully you've done that on your paper. But let's put this to work. Number 1 says the weights of 50 football players are normally distributed, see that's key, with a mean of 178 and a standard deviation of 8 pounds. So let's start right here. Where does this mean of 178 go? Well, your mean, your average, goes right smack dab in the middle, 178. Now, what do I do from here? Well, from here, it's all about your what? It's all about your standard deviation. What does this one say that our standard deviation is? It says that it's 8 pounds. So what does that mean? How do I deal with that 8 pounds? Well, as I go to the left, 1 standard deviation to the left of 178, I'm simply going to, kind of like margin of error yesterday, we're going to subtract 8. What is 178 minus 8? 170. What's 170 minus 8? 162. What's 162 minus 8? 154. So 154 is 3 standard deviations away from the mean. 162 is 2 standard deviations away from the mean. And 170 is 1 standard deviation away from the mean. Let's go the other way too. What's 178 plus 8 this time? That's 186. What's 186 plus 8? Well, that's 194. And then 194 plus 8, that's 202. So these are my standard deviations in the opposite direction. So here's what I would love for you guys to do. I would love for you to get in the habit of going ahead and writing what all these percentages are. This is 34, 34. This is 13.5, 13.5. This is 2.35, 2.35. And this one is 0.15 and 0.15. Okay, and those are our outliers. Anything else would fall outside those regions. So look at all of our questions based on this now. Okay, and I'm going to use a highlighter. You can't use this as well as I can because I can erase quickly. But look at what it says. What percent of the players weigh between 178 and 194? Well, I just need to find those. 178 is here, and 194 is here. So start at 178, stop at 194. What percentage of players does that include? Well, it includes 1 standard deviation, 2 standard deviations to the right. It includes 34 plus 13.5. Well, what is 34 plus 13.5? That's 47.5. So 47.5% of players are out there between 178 and 194. What's the next one say? What is the probability that a player weighs at most 170? What does at most mean? At most means 170 is the highest amount, right? So we want to look at 170 and below. So if I look at 170 and below, that includes all of these 3 categories over here. So add them up. What's 13.5 plus 2.35 plus 0.15? Add those up, and you get what? 16%. 16% live out there and have a weight at most of 170. Okay, let's look at the next grouping. The next grouping says, what is the probability that a player weighs less than 162 or greater than 194? So less than 162, where's that at? Well, that's here and to the left. And what about greater than 194? That's this way and to the right. So we're simply, or means we're gonna add those up. So on the left side, that's 2.35 plus 0.15. And then on the right, that's 2.35 plus 0.15. So 2.35 plus 0.15 plus 2.35 plus 0.15 is 5%. 5% weigh either less than 162 or greater than 194. Hopefully that makes sense. All right, next one. Last one for this problem. How many players weigh between 170 and 186? So here's 170, and we go all the way over to where? 186. Well, there's my 1 standard deviation from the mean, right? That's 34 plus 34, which is 68%. 68% weigh between 170 and 186 pounds. And that's it. That's kind of how you do these problems, okay? They're not overly difficult. You just need to be able to remember that your mean goes right smack dab in the middle and that your standard deviations go to the left and to the right, and then try to start memorizing what all these different percentages are because those don't change, okay? That's how normal curves work. So let's look at this one, number 2. A set of 120 test scores are normally distributed with a mean of 82 and a standard deviation of 5. So what number goes right smack dab in the middle? Well, 82 does, right? 82 goes right in the middle. And then what are we going to do as we move off to the left? We're going to just keep subtracting 5, right? we're going to keep subtracting 5. So what is 82 minus 5? 82 minus 5 is 77. Okay, let's subtract 5 from that. That's 72. And let's subtract 5 from that. That's 67. So we got 67, 72, we got 77, and 82. Now let's go to the right. What's 82 plus 5? 87. 87 plus 5? 92. And 92 plus 5? 97. Okay? That is my mean and all of my standard deviations in both directions. So now let's add these values that we've been talking about. So what's in the middle? 34 and 34. What's my next two groups? 13.5 and 13.5. What's my next two groups? 2.35 and 2.35. And then finally, what do we have on the outsides? We got 0.15 and 0.15. So now let's just answer some simple questions. What percent of the scores are between 72 and 87? So 72 is here, and 87 comes all the way over here. So what do? We add up the area that we're talking about. So from left to right, that's 13.5 plus 34 plus 34. So that's 81.5%. Okay, that's done. Let's look at the next question. What is the probability that a score is greater than 77? Look, well, 77 is all the way from here and over. Now, I want you to just think logically here. What do we know lies from this point right here over to the right? Isn't that 50% of our data? So we got 50% of our data plus 34. So what's 50% plus 34? 84%. 84%. Or, listen, you could always go 34 plus 34 plus 13.5 plus 2.35 plus 0.15. You're welcome to do that, but just remember there are sometimes faster ways. Okay, next one. What is the probability that a score is less than 82 or greater than 92? Okay, so less than 82. Here's 82, so less than that means everything from the middle over. So how much is that? Well, again, you can add them all up, or you can know that that's 50%. And then how about greater than 92? Well, that's 2.35 plus 0.15. So we got 50 plus 2.35 plus 0.15, which is a total of 52.5%. 52.5%. Add them all up, you'll see that. And then the last one here for this particular problem, about how many students scored outside 2 standard deviations of the mean. Well, remember, this is 1 standard deviation, this is 2. So outside of 2 means out here, this is 1 standard deviation, this is 2. So outside of 2 means here. So this is the portion we're talking about being outside 2 standard deviations of the mean. Well, that's 2.35 plus 0.15 plus 2.35 plus 0.15, which we've done earlier, is 5%. The question that was asked earlier was a little different than that, but that's how you do it. Okay, pretty simple. I hope that you guys understand that. I'd like to do one more. I don't want to do all of these. So we're going to skip down here to number 4. And I'm going to do this problem and answer the questions on it. So let's look at it. It first tells me that Mrs. Fuller recently tested her 120 keyboarding students to see how many words per minute they could type. The results were normally distributed with a mean of 45. Okay, so look, guys, 45 in the middle. And a standard deviation of 6. So we're going to subtract 6 to the left. That's 39 in the first spot. We're going to subtract 6, keep on moving, that's 33. We're going to subtract 6, keep it moving. That's 27. That's as far as we're going to go to the left. 3 standard deviations from the mean. Anything under that's an outlier. Now let's go to the right. 45 plus 6 is going to be 51. 51 plus 6 is going to be 57. And 57 plus 6 is going to be 63. And that's as far as we have to go that way. Once again, I like to get in the habit of writing all my percentages down. So that's 34, 34 in the middle. That's 13.5 and 13.5 in the next standard deviation. That's 2.35 and 2.35. And finally, that's 0.15 in the outside and 0.15 in this outside. So let's see what questions are asked here. About how many students can type at least 39 words a minute? What does at least mean? At least means at the least. At the least. That means 39 is the smallest amount. So we want to know who can do 39 or more. Well, remember, we're talking about all of these from this point forward, right? So I could either add all those up, 34 plus 34 plus 13.5 plus 2.35 plus 0.15, or I could remember that this portion right here from the mean over, that's 50%. So 50% plus 34% is 84%. Okay? All right, let's erase all this and go back and see what the next question is. About how many students can type within one standard deviation of the mean. Within one means that I can only go one to the left and I can go one to the right. So we really shouldn't even have to look at that. We should know that how many people does that include? Well, it includes, not percentage-wise, but it includes 39 to 51. No, that's wrong. I'm sorry, I misread that question. It is percentage-wise. How many students? Actually, this is a tricky question, and I just now noticed it. In fact, I need to discuss letter A as well. It says about how many students. See, it's changed the wording. In fact, I need to go up here and talk about D on this problem as well. Number 2. I need to do it on number 1 as well. Let me change my instruction just a little bit. It says on A, about how many students can type at least 39 words per minute. Well, it is 84%, but it's 84% of what? It's 84% of 120 students. So what I want you to do is, I want you to type in your calculator 120 times 0.84, okay? And when you do that, it's 100.8, 100.8. So approximately how many can type at least 39 words per minute? 101. So these questions are asked a little bit differently, and I'm just noticing that. So let's go back up here to number 2. A, we were good. It says what percent? B, what is the probability? We're good with that one too, because even though probability is generally written as a fraction, we know that 84% is still probability. C, we're good with that one too. But look at D. It says about how many students scored outside 2 standard deviation. Well, it's 5% of my students. But how many were there? There was 120. So we're going to do 120 times 5%. Now, how do I do that? That's 0.05. So 120 times 0.05 is 6. There are 6 students who can type outside of 2 standard deviations from the mean. And then go back up here to number 1. A says what percent, we're good there. B says what probability, we're good there. C says what probability, we're good there. But look at D. How many players weigh between 170 and 186? Well, it's 68%, but it's 68% of 50 players. So type in your calculator 50 times 0.68. Remember, we're just changing 68% to a decimal, and that gives us a total of 34 players. So I apologize for that. I didn't realize until just now that that's what it was asking. So let's look at B. It says about how many students can type within 1 standard deviation of the mean. Well, that's 68% of the students. But how many would that actually be? Well, it's 120 times 0.68, right? Times 81% or 68%. So that's 81.6 students, which would round up to about 82. About 82. All right, and then let me erase this. And again, I'm sorry that I messed you up. Hopefully you went back and changed those. But C says students need to be in the top 2% in order to be eligible for the national typing competition. If Carla can type 56 words per minute, is she eligible? I want you to think about this. Where does 56 words per minute fall? Well, it has to fall right in here, doesn't it? Just below 57 is 56. Well, how many people are just above her? 2.35% plus 0.15% is 2.5%. She's got to be in the top 2%. Does she make it? No, she is not eligible, unfortunately. She's really close, but she's not quite eligible. Okay, so when you're reading these problems tonight, when you're doing these problems tonight, make sure you see the difference between the mistake that I made when it asked you specifically about how many students versus just saying what percent or what probability. Okay, so that was my fault. Hopefully you guys see that difference, and you'll be able to do it in your homework assignment. Okay, so at this point, the substitute is going to give you your homework assignment. The good thing about the homework assignment is it's only front side only, and I want you to do all of these 7 through 10, numbers 7 through 10. That only sounds like 4 problems, but 7 has 3 parts and 8 has 3 parts. So again, this is your homework assignment for tonight. Tomorrow we'll discuss it. We'll also discuss any questions that you had over last night's assignment, and we'll probably discuss normal distribution a little bit more and call it a week. So hope you have a great Thursday. Look forward to seeing you tomorrow.